Hi, my name is Dana, and today I'll be talking to you about aromatic compounds. So aromatic compounds are also known as arenes. They're cyclic, planar, and conjugated, which makes them incredibly stable. They are originally isolated from fragrant oils, which is where they get their name. Aroma, aromatic, same root. But not all of them smell good, so not all of them have that aroma that they're so well known for. And they're heavily used in pharmaceutical drugs. And so here I have examples of two aromatic compounds. So first is benzene. Benzene is sort of a building block. So you'll see it again in a lot of other examples that I pull out for throughout this video. But benzene is a very common aromatic compound. It's very simple. And here is Zoloft. I'll go kind of more in depth about it later. But as you can see, it's made up of two benzene rings here. So in order to be an aromatic compound, it must fulfill certain criteria. So first, it has to be a fully conjugated ring with overlapping p orbitals. So that means that there's no space in between these pi bonds. So obviously, you can't have two pi bonds in a row, but you'd want to have sort of one little gap in between them. But if you have a pi bond and then two carbons in between and then another pi bond, obviously it's not conjugated. So it must be cyclic, so that's a big component. It also must be flat. So the flatness and the conjugation are kind of what makes it so strong. So when it's flat, it's not bending or twisting, which won't cause the molecule any stress, which is kind of why it's so strong. It also must meet Huckel's rule. So Huckel's rule states that it must have an odd number of electron pairs, and it needs to fulfill the equation 4n plus 2. So down here, I have a couple examples of what that is. So we have 5 molecules here, 3 of which are aromatic, 2 are not. And so here we see for the first molecule, this little triangle, we see 2 pi electrons. So we have 1 pi bond, which means 2 pi electrons, and that makes it aromatic. So when n equals 2, 6, 10, and so on, we know that it's going to be an aromatic compound. So in the second compound, it is fully conjugated, it is cyclic, it is flat, but the number n is not sufficient for it to be aromatic. So 4 total pi electrons does not make it aromatic. And we see the same thing happening here in the 4th molecule. So what's the importance of this? So aromatic compounds occur everywhere in nature, and we see them a lot in biological systems. So in 4 of the amino acids, so the building blocks of proteins, we see this aromatic compound. So in histidine, phenylalanine, tryptophan, and tyrosine, those all have aromatic compounds within them. We also see it in DNA. So all 5 nucleotides in DNA and RNA are aromatic. So that's adenine, thymine, cytosine, guanine, and uracil. So here at the bottom, I have some examples again. And here is adenine, and as you can see, it is aromatic. We have cytosine, which has a really similar sort of structure as adenine. We have histidine, which has an aromatic ring and then a chain kind of attached to it. So not the whole molecule doesn't have to be a ring in order for it to be considered aromatic. It just has to have one aromatic ring within it. And here also is tryptophan. So tryptophan is very famous for being the amino acid that makes you sleepy after eating all of that turkey on Thanksgiving dinner. So little did you know, it's actually an aromatic compound. So what are the uses? So a lot of pharmaceutical companies have utilized aromatic systems and made different drugs that you can use in your body. And so one of the benefits, well, I guess there are two main benefits of this. So one benefit is that your body already recognizes these aromatic rings. As we saw just before, it's everywhere in your body. It's in your amino acids, even in your DNA. And so it also creates a very stable structure. So as I said before, they're really hard to break, and they're not very reactive. So that means that when you create a drug with an aromatic ring, then it's probably not going to react with some random molecule within your body. So in fact, 8 out of the 10 top pharmaceutical drugs have aromatic systems, so they're very popular. So here are two examples. So here we have Nexium, which is a proton pump inhibitor used in the treatment of ulcers and acid reflux. So there you go. If you have a stomach ulcer, you take Nexium, and it helps repair your body. It just becomes a part of the system itself. And also here we have Zoloft, so it's used in the treatment of depression. So here's a neurological drug, so it reacts within your brain to create a better system to hopefully relieve your depression. And as you can see, both of them have both of them have benzene rings that are aromatic. So yeah, I hope you enjoyed this. I hope this gave you a good overview of aromatic compounds, and thank you.